So the way that you find the mass of the central object is you have to have something like a moon or whatever orbiting the object. And if you have that, then what we can do is the same thing as we did yesterday. We can do the sum of the forces equals ma. And remember, it's the gravitational force that's causing that object to orbit. So we do big G, m1, m2 over the distance between the centers squared equals m, and since it's going in a circle, acceleration is v squared over r. Same thing as yesterday, the orbiting mass can cancel out, and because the distance from the centers is the radius, one of those values cancel out. So everything is the same as what we did yesterday up until now. It's just yesterday we were trying to solve for v, so we moved everything and we did the square root to get that. Today, we're trying to find the mass of the central object. So to do that then, we have mass equals, and then over on the right-hand side, we already have v squared. And then we need to divide by big G to get that to cancel out. So over on this side, we have to divide by big G. And then we have this r in the denominator, so we have to multiply by r to get that to cancel out. So we have an r here. And that gives you the mass of the central object. The only other thing, though, is you're not going to know v. V isn't just like given in these problems. What we did, the scientists don't just like have a radar gun and they shoot it at the moon and it says, oh, the moon's going this fast. So what they have to do is they have to use the idea that v is just like speed, which is distance over time. And the distance that it goes as it travels around the planet is that circumference. So that's 2 pi r. And then, they can use a watch or something to time how long it takes. So that is v. So that's going to get substituted up into the v there. So what you're going to get in this case then is m. V is 2 pi r over the time. And then that is squared times r over big G. And then if we multiply all this stuff out, we get m is 4 pi squared. And then we have r squared times another r, which is r cubed, over t squared big G. So that's actually what's going to give you the mass of the central object. Again, don't feel like you have to memorize this thing. It's a pretty ugly equation. But just think about the steps that you have to go through to get to that. And if you want, you can even calculate this v ahead of time and get a number for it, and then just put that number in for v squared. You don't have to bring all the pieces over. You can just get the number for that. But that's how you get the mass of the central object. You still start with F equals ma, and it's gravity, big G, m1, m2 over r squared. A is v squared over r, and then just shift your variables around and solve for m instead of solving for v.